so here we go. We're given that f of x is 3x plus 2 and g of x is 2x squared minus 1. We want to find f of g of 4. That says in the function f, you're going to stuff g of 4. The one closest to this second set of parentheses is the inside, and the outside is the outside. Now g of 4 is the y value when x equals 4 in this second function. So I'll calculate out what g of 4 is. G of 4 happens to be 2 times 4 squared minus 1, which is 2 times 16 minus 1, which is 32 minus 1, or 31. So what I'm looking at now is f of g of 4 is 31. Now I use the function f and find f of 31, which is 3 times 31 plus 2, which is 93 plus 2, or 95. Now, if I want to go the other direction and say, find g of f of 2, this says in the function g, I'm going to stuff f of 2. So now I'm going to start with f and calculate out f of 2. Well, f of 2 is 3 times 2 plus 2, which is 6 plus 2, or 8. So what I really want is g of 8. Now g of 8 is 2 times 8 squared minus 1, which is 2 times 64 minus 1, which is 128 minus 1, which is 127. We create composite functions more than anything. And sometimes when we're looking at a composite function is a function also which is given to us. And calculus is always given to us. We don't create it, it's given to us. Here, we're also going to create some of them as well. A function inside of the function. Now, the description here says, in problems 29 through 44, for the given function f and g, and then it says, state the domain of each function, composite function. Just forget about doing the domain. Don't usually have to worry about that unless you're in upper division math classes. Then you worry about that, but you don't worry about that even through calculus. You don't worry about it. So at that point, you worry about the domain of the resulting function, not the domains of the original functions and what happens when they're composed. It's not worth our time in this class to spend on it. So if I look at f fog, which is f of g of x, that says in the function f, I'm going to stuff the function g wherever I have an x. So when I look at this, it says I'm putting g into f. So essentially f of g of x, I'd look at taking the x's out, and wherever I have an x, I'm going to put the function g of x. That's what it says to do. It says, take the x out and put g of x in its place. Well, g of x is 2 over x. And now I've got a complex fraction. That's how complex fractions come about, by the way. But they're nice, because here the common denominator is x. So I'm going to multiply by x over x. So this says I've got 2 over x divided by 2 over x plus 3x over x is 2 plus 3x over x. If the denominators are the same, you add the numerators. And now you just invert and multiply. So it's 2 over x times x over 2 plus 3x. The x's reduce out, and you're left with 2 over 2 plus 3x. I cannot reduce it any further because these 2's don't reduce out. Remember, because of that addition sign, that is a grouping. So it's all or nothing. So that's what the composite function is. And I know the domain of this guy is what? All real numbers, x can't be negative 2/3. Yeah. Now if I want to go the other direction, which is Goff, this says in the function g, you're going to stuff the function f of x. So if I'm looking at g of f of x, that says in g, which is 2 over x, I'm going to put the function f of x, because that says that's what you do. Which is 2 over f of x, and f of x is x over x plus 3. And now you invert and multiply, so you have 2 over 1 times x plus 3 over x. And you're left with 2 times x plus 3 over x. And in this particular case, x cannot be 0. So we worry about the end, not the beginning, at least not in this class.